Okay, so I hope that you tried to do examples 2 and 3 on your own, trying to find the GCF between these two pairs of numbers. If you didn't, okay, I'm really not surprised because y'all don't like to think you want me to do all of it. But anyway, I'll do the thinking for you on this one. For number 2, I'm trying to find the highest number that can be multiplied into both of these. Now, like I said, if you can't do this by hand, you can't remember your multiplication tables. First of all, the calculator really won't help you. This is like 100% mental math. Set up your information in a table. And then the highest number that you see is the greatest common factor. The highest number that they share is the greatest common factor. So for number 24, if you need to make this table, if not, do it in your head. Either way, you should realize that 24 is the greatest common factor. 24 is a factor of itself, and it's a factor of 48. That's the GCF, okay? For number 3, you've got 17 and 51. So I take it back. The calculator might help you a little bit if you're trying to find factors of larger numbers. You could say, okay, does 51 go divided by 2, divided by 3, all that kind of stuff. If you did that, then you would realize that the GCF is 17. 17 is a prime number, so its only factors are 1 and 17. 17 is also a factor of 51. Either way, you've got to use some of that mental math. I'm sure you are just floored at how third grade math is actually coming into play in quarter 4 algebra 1. But it's all connected. It's the circle of life. You know what I'm saying? So for number 4, this is kind of what you're going to be experiencing because you may have more than 2 numbers. So you got to find the GCF of the entire polynomial. If I give you a polynomial with 10 terms in it, you got to find the GCF across all those 10 terms. So what I suggest, if it's difficult for you to figure it out with 2 terms, you probably just want to make a table when you have more than 2. So I'm just going to set it up. All right, my factors of 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 20. These are all the numbers that go into 20. Then I do the same thing for the 28. 1, 2, 3, 4, 5, 6, 7, 14. All right? And then for the 40. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I think it goes, I don't know if I'm missing any after that. I think it goes straight to 40. So, 20 and then 40. 20 and then 40. So then I just look, what's the largest number that goes into all 3? And I think it is, I don't want to write down, I want to be right. Yep, 4. This is the number that they all share, the greatest number that they all share, so the GCF is 4. Do this work. If you don't want me to know that you're doing it because you're like, I want Mrs. Udoka to think I'm so smart I can do this in my head, that's cool. You just go over to the side and you write it on this little slip of paper. I don't care how you do it. Just make sure that you get that GCF right. Because if you don't get the GCF right, your factoring is going to be totally messed up. All right? So this is just a little practice of finding the greatest common factor of your numbers. But you know that polynomials have variables all in it. So we also have to talk about finding the GCFs of variables. So let's turn and look up here. All right? We also have to find the GCF of variables. Now this may be kind of new to you, but it's something that we have to do. So hopefully you turn your, I think you got to turn your page and you'll see where this is written. Finding the GCF of variables. So I'm just going to go straight to it. I'm going to give you the shortcut so that you can just eyeball it. So here's what I want you to write. To find the GCF of variables, the shortcut is you're going to take the variable. You see me? You see that? With the lowest exponent. All right? You're going to take the variable with the lowest exponent. Remember, this is common factor. So you want to know how many x's or y's or t's does each term share. Well, that'll be the lowest number of variables that you have. All right? That's the number that they all share. Okay? The lowest exponent will be your GCF. I'm going to say it again. The lowest exponent will be your GCF. Now, let's add one more thing. If your polynomial has a constant, so it's just a number, then there is no GCF variable. Because your constant has a degree of 0. It's a number raised to the 0, x to the 0 power. That's your lowest exponent. There is no GCF for the variable. So what we're going to do is I'm going to try to get my big head out the way. You write this down, okay? Write it down. And then in the next video, I'm going to show you what that looks like. We're going to combine some numbers and variables together.